Hey everybody, this is Alex Merced and welcome to another episode of Gnarly Data Waves. And today we're going to be talking about how to simplify data governance at scale across all your data. Now, but before we get started, let's talk about how you can get yourself hands-on with the data lakehouse. Just head over to dremio.com and click on test drive so that way you can try at no cost, no obligation, try out the Dremio platform and see what it's like to run queries using the easy, fast, and open Dremio platform on your data lakehouse. Also, make sure to get an early copy of the Apache Iceberg, the definitive guide. Just scan that QR code. We're constantly adding new chapters to the early release. So, if you've read it before, take a look again. There might be more chapters there. Just scan that QR code right there. Also, we have many upcoming episodes to Gnarly Data Waves, such as next week. I'll be talking about using Dremio and DuckDB together. We'll have other episodes such as It's Time for an Even Easier Data Lakehouse, Learn What's New in Dremio, and ELT, ETL, and the Dremio Data Lakehouse, all to kind of just keep diving deeper into different topics regarding the data lakes and data lakehouses, here on Gnarly Data Waves. So make sure to keep tuning in every Tuesday and subscribing on Spotify and wherever you listen to podcasts. Dremio is going to be at the following events: Big Data and AI Paris in September, Big Data London also in September, Coalesce by DDP in October. So make sure that if you're at those events, check out the Dremio booth where you can get some cool swag and meet some cool people. So go pay us a visit. But with no further ado, I'm going to introduce you our presenter for today, talking about how to simplify data governance at scale across all your data. I'll introduce Colleen Quinn, product marketing here for Dremiosonar. Colleen, the stage is yours.
Hi, everyone. My name is Colleen Quinn, and I'm in product marketing for Dremio. Thank you all so much for joining us this week for our gnarly data wave called Simplifying Data Governance at Scale Across All of Your Data. Before we hop into the content of our session today, I want to talk a bit about a common data and analytics pain we all face, and a bit about how Dremio helps solve it. So it's no secret that as data volume, velocity, and variety increases, it gets even harder to securely put data into the hands of users across your organization so they can make data-driven decisions to drive your business. This picture says it all. So data warehouses are complex and costly to scale. Data lakes often become data swamps that lack data quality, and they are very hard to govern. And IT teams are constantly needing to move data from the lake into the warehouse to prepare it for analytics. These additional copies of the data increase governance surface area and often result in stale data with no single source of truth. Adding on to that, different users want different tools to analyze the data. Data analysts want BI tools, data scientists want notebooks. Best-of-breed analytics that sit on top of the data warehouse are expensive and piecemeal, and all that layers on additional complexity. And to top it off, you're often locked in with proprietary formats and have limited exploration capabilities. So it's basically very painful. So that's where we come in. Dremio makes it easy to deliver an agile, flexible, and open data lakehouse. Dremio enables a seamless, intuitive semantic layer over all of your data, wherever it lives, without endless copies of data and complex ETL. You can analyze data from data lakes and data stores with no data movement. You can also manage data quality, recover from errors, and audit data usage across your data lakes. And Dremio is open and cost-effective. It saves time and reduces IT management, and it's fast with sub-second BI performance. All of this with scalable, centralized data governance. Which brings us to our topic today. So today we're going to take a closer look at data governance in particular, and we'll talk about why data governance is important. Then we'll dive in and we'll focus on 3 key technology considerations that facilitate improved governance. We'll look at data architecture, data security, and then compliance and data quality. But first, I would like to tell you a little hypothetical horror story, one that plays out daily in lots of organizations. So it all starts with a data lake. And frankly, we probably have more than one data lake. We have data lakes that span different cloud providers. We probably also have data that sits in data warehouses and data that sits in relational databases. So I need to analyze some of that data. My boss has asked me to gather some data so that he can provide a critical business update. Sounds good, right? So that's where my data engineer comes in. So she pulls the data from the data lake, then she'll cleanse and normalize that data and transform it. And then She'll load that data into an EDW or enterprise data warehouse. And that EDW can be either in the cloud or on premise. Okay, so now it's my turn. I have a number of analytics tools at my disposal, but I prefer Excel. So I export a copy of the data onto my laptop. And now I look at the data set and I see it has a lot of data that really isn't relevant for what we need to do. So I delete rows and columns and I clean that data up some more. And I want to make sure it's exactly what my boss needs. And then I email that data set to him. All right, so now he opens the file and he saves that onto his laptop. By the way, we also use Google Suite, and he doesn't regularly delete his email. Neither do I really. Now, since he has a clear picture of, the analytics need in question, he's also going to massage that data and make updates. And then when we're both done, we upload that data set, which, if you've been following along, is now 2 different data sets back to S3, and our problem is solved. If you were keeping count at all, you can see that we now have at least 5 additional copies of the data, maybe more if you count what's been saved in our respective email accounts. And if you're interested in data governance at all, this should really stress you out. So let's talk about what's really happened in this scenario. For starters, we've created more data to store, those additional 5 copies. Now, object data storage is reasonably inexpensive, so maybe it's not a cost issue yet. We've also expanded the surface area of the data we need to govern. So now I've got multiple copies of that data over which I have no control. Third, because we each loaded our revised data sets back to S3, there's no single source of truth. So which data set will be the right data set the next time we need to ask that same business question again? And what if somewhere along the way we introduced errors into that data? And what if that data then becomes used for downstream production activity or analytics? And finally, we have totally increased our compliance and regulatory risk. What if there was PII in the data set that we were just shipping around willy-nilly with no security in place? I would just like to say for the record that we don't actually do this at Dremio, and using Dremio is how we solve for this problem. So there's no question that data governance can be complex, but it's also critical. Data governance leads to improved data quality. Data governance makes it easier to adhere to compliance and regulatory requirements, and then make corrections along the way to ensure that we remain compliant as needed. And a strong data governance program also helps safeguard sensitive information and protect against unauthorized access. So when you think about data governance, it's really important to think about governance, as I'm sure everyone in this audience knows, as a collection of 3 things: processes, policies, and systems. And these things work together to ensure that data is accurate, reliable, secure, and accessible. Since we only have a short time together today, we're really just going to drill in and focus on the technology and systems component. And so we'll just talk about 3 of the most important technology considerations when it comes to data governance. And as I mentioned earlier, they are data architecture, data security, and compliance and data quality. So we saw that chaotic slide earlier, where the endless spaghetti lines of data are moving from data lakes to data warehouses, to analytics and BI tools and back. The wrong architecture can increase data governance complexity or make it almost impossible. When you think about traditional legacy data architectures, they make it really hard for companies to put all of a company's data in the hands of all the right users to make decisions. Data is often siloed across the organization, slowing access to data and then slowing business decision-making. And ultimately that impairs your business's ability to be agile. It can take days, as many of us know, for data engineers to move data from data lakes to data warehouses, and then to ensure that that data is prepared and ready for analytics. And so by then, the data that I'm using might already be stale. And not to mention that data warehouses can be really expensive, and they're just not meant to scale to the incredible data volumes that most organizations are managing today. This latency, this lag time, getting the data from the lake to the warehouse, this is why so many users often resort to making data copies and sometimes sharing that data outside of their sanctioned architecture, like you saw in our example. And so when data copies are created and not governed, the businesses lose that single source of truth and they expose themselves to greater risk. Also, silo data makes it almost impossible to apply data governance. Most companies don't have a complete data inventory. And so when you don't have that centralized data catalog or management, that too increases the complexity of applying granular data permissions. And so then what happens is you have a patchwork of access control applied at various data sources and often without consistency. So what are some architecture characteristics that can simplify and scale data governance? Well, there may be other approaches to achieving these architecture traits. We think Dremio is the best example of how to go about it. So first, you need to make your data lakes the core of your analytic work. And so that means you're able to analyze the data at the source in the lake and also make your data lake transactional. And so when you can analyze your data in the lake at data lake scale with the speed, ACID compliance, and flexibility and simplicity of a data warehouse, we call that a data lakehouse. Then you need to unify all of your data wherever it lives, whether that's in the cloud, across multiple clouds, or on-premise. Your architecture should actively move you away from the need for endless data copies, which again, increase that total surface area needed to be governed. It should also help you reduce or eliminate the need for ETL and data movement, which again also introduces greater risk. Finally, your architecture should support easier data sharing and discovery. When data can be securely shared and easily discovered, users are less reliant on moving data to complete their work. So let's take a look at how you can unify and manage your data with Dremio. Dremio unifies your data with no data movement. So you can analyze your data where it lives, whether that's in the lake or the data warehouse. And as I said earlier, whether it's in a cloud, across clouds, or on-premise. Dremio enables an easy and open data lakehouse built on open source technologies, including apacheiceberg and Aeroflight. And this is important so that you have confidence that you're never locked into a single vendor, and also that you can kind of take advantage of new innovations in open source as they happen. Dremio's unified semantic layer lets you connect and govern your data through a really intuitive semantic layer. You can apply governance at the data source, all the way through to unique views of the data that you create, views that are designed to support your various business and data initiatives. But we'll talk more about access control in a moment. And then those views, which again, think of them as views based on a business project that you need to accomplish or a data initiative, can be securely shared with appropriate data users who are collaborating with you on that data project. And you can do all of that without ever needing to move or copy any data at all. One of the first things that I always think about when thinking about my data ecosystem is, what can my data infrastructure actually connect to? So this is a view of Dremio's partner ecosystem. And so you can see when we talk about data governance that Dremio integrates with authentication, data privacy, and governance technologies like Okera and Privacera. So you can integrate with your existing security controls to ensure consistency. Okay. So we talked about data architecture. Now let's talk about our second core technology component, data security. So data governance is vital to improving data security. And data security hinges on traceability, knowing where your data comes from, where it currently is, who has access to it, and how it's ultimately used. So as more users need more access to the data, deploying user permissions at scale or data permissions at scale requires constant vigilance, and it is very time consuming and manual. Most data lake management lacks the consolidated ability to manage metadata and data permissions in one place, which is easy to do in a database because they're a single resource. And then applying granular permissions at the table, row, and column level isn't always possible. Finally, it's really hard to understand how your data users have access and how they're using your data. So incomplete or piecemeal data access auditing creates regulatory and compliance risk, and also creates gaps in understanding who's doing what with your data and when. So protecting your data means being able to strike the right balance between data security and access. You want your users to be able to conduct the analytics and BI that they need to move the business forward, but you also need to balance that with control. So it's essential to be able to govern data access across organizational boundaries with tools that are intuitive for both the business and engineering users. You need to be able to manage permissions at the role level using role-based access control. This is what allows you to scale your permissions more easily, but you also need the flexibility to do that at the user level when needed. You need to be able to grant precise access. This means that you need fine-grained access control and fine-grained permissions. And you need to be able to grant and restrict access at the table, row, and column level, and also do that on demand as things change. And you should have the flexibility to determine the actions that a user or role can take, whether they can edit the data, view the data, create a new table, and so on. So what you're seeing here are two different views in Dremio, where I can easily manage permissions either at the data source level in the above case. You can see it's an S3 bucket, and I can manage using role-based access control or by an individual user. As I also previously mentioned, I can also create views. We call them spaces in Dremio, and these are for logical analytics or BI projects being worked on. You can see examples of these spaces or views in the image on the right. And these projects can span data sources across my organization. So I can create a view using multiple data sources, and that data can be anywhere. The data can be in the cloud, across clouds, or on-premise. It can be in object stores, meta stores, or even other databases. And I don't need to move that data into Dremio to do this. I can operate and analyze on my data at the source. And then I can build and govern views across these data projects and share those projects with users. And I can be really confident that the data is fully governed. So together, these capabilities also make it easy to deliver data sharing architectures like a data mesh, where individual data owners can manage access to and the sharing of their data sets. Okay, so we've talked about architecture and we've talked about security. We're in the home stretch and we're going to talk about the role of compliance and data quality and data governance. So when businesses start thinking about data governance, they usually do that because they know they need to comply with regulatory policies like GDPR or HIPAA. A recent Dataversity report said that 48% of companies ranked regulatory compliance as their primary driver for governance. The other drivers were making better business decisions and analytics, what we've also been speaking about. So these regulations require organizations to be able to trace their data from the source to any data retirement, and then also be able to identify who has access to that data and know how and where that data has been used. So these last two criteria require extensive, complete data access auditing, which is impossible when users are handling data outside of the sanctioned tools in your data architecture. Sensitive data is also at increased risk when data is not well governed. You saw that in our example earlier in this presentation. If PII isn't locked down, that data can get into the wrong hands. And in our scenario, email that around, which is very risky, and you should not do that. Finally, poor data governance can also affect data quality. As I said earlier, data lakes can easily become data swamps. It's so essential to be able to track the lineage of your data for reliable analytics and for compliance purposes, and then to be able to detect and remediate data quality errors when they happen. So the technology that you build your data governance program with will absolutely help set the stage for more confident regulatory compliance and improve data quality. So it's essential that your data management tools enable comprehensive data lineage, again, a regulatory requirement, from the source through the data lifecycle. Here you can see an example of how Dremio does this today. So the view I created on the right can be traced all the way back to the parent data sets. One is a view and one is a raw data source. You can also see that one data source is Postgres and the other is an S3 bucket. I can easily drill into those raw data sources for more insight. You also need to have the ability to complete data access auditing. So again, you know who accessed the data and what actions they may have taken. We already talked about fine-grained access control. Applying fine-grained control to protect sensitive data or personally identifiable information is critical to protect your business and your customers. And governing data access is most effective when the data owner themselves can grant and revoke access to the data on demand. Because compliance and security are so important, it's also important to make sure that the technology choices that support your governance program adhere to an array of security and compliance certifications. So Dremio's security portfolio, for example, supports GDPR compliance, HIPAA compliance, SOC 2 Type 2, and ISO 27001, among others. I talked about data errors earlier as a risk to data quality. So when users are working in the data scientists for experimentation, let's say, or data engineers building ETL pipelines, it's really easy to introduce errors. These errors can affect your customers and the downstream decision-making of your business, and it can take many stressful hours or days to correct. So I want to introduce you to Dremio's concept of data as code. Really just think about how software engineers build software. They build initially in a dev environment, then they thoroughly test their software, and only when they're confident that the software is mostly bug-free, they merge that code back into production. Dremio lets you apply this concept to your data. You can create and manage data versions, and so that's what we call data as code. You create new separate data branches that are isolated from the main branch. And so really, your data scientists can experiment without impacting production data or other users. You can also create data pipelines, virtual data pipelines, and ingest and curate that data and test it before merging it back into the main production branch. Data as code also provides version control, so you can time travel and use historical data to reproduce models and dashboards, or you can roll back and recover from errors that impact production data or systems. And as I mentioned previously, Dremio also centralizes and scales data governance. It allows data product owners to delegate permissions to manage that data easily, and it provides that comprehensive auditing of the data access and usage. Okay, so as we wrap up, I just wanted to share a little bit of insight from a recently conducted IDC research. So in that research, IDC found that 85% of businesses want to be data-driven, but only 37% say that they've been able to do that. The same report also said that governance is no longer optional, that data is an asset that absolutely needs to be protected. And the report also found that companies said that 30% of the time that they spent on data governance was wasted. The bottom line is that most companies find data governance really difficult. I hope today's presentation helped you think through how you can better deploy and manage data governance in your organization and how Dremio can help. Thanks so much for joining, and we'll be able to take some questions.
Welcome back. Time for some Q&A. And we got a couple questions on the way. And again, if you have any questions, just put them in the Q&A box or in the chat. I am monitoring both for any questions you have about the presentation we just had from Colleen. But I see one question from earlier that was, let's get back to that. How are you protecting sensitive data like medical information, PII, credit card info, etc.? Now, I think that kind of got addressed later on in the presentation, but again, Dremio has a variety of security certifications and a variety of mechanisms for you to kind of limit access to the data. So not only can you control it by user and row, but you're able to do column masking, row masking at different levels. And you're able to control it by not just like, let's say, an individual data set, but at the folder level, at the space level. So you have a lot of different levers for controlling access, because at the end of the day, Dremio doesn't store data. So what Dremio controls is the access through Dremio. So the idea is that you use Dremio sort of as your funnel for access. So you're connecting all your sources and all your data is kind of going through Dremio as a funnel. And then everybody just kind of accesses through Dremio. So that way you only have one place where you have to set your governance rules. And basically you have all that auditability because everyone's kind of accessing it from the same place. So you can see what queries they have, you can see what data sets they curated from the data you gave them access to, and through the lineage features and all that. So basically the idea there, then you have it nice and secure. You kind of know, you may have 10 different data in 10 different places, but you know exactly who has what access to what, and you only have to set that in one place. And then essentially you, for the most part, lock down any other kind of access outside of that. So that way, you know, hey, they have to kind of go through this one door where I can perfectly sort of track and audit access to that data. And also they get easy access to that data. Now, is there any data discovery capabilities? Yes. So Dremio has a built-in catalog, whether you're using Dremio software or Dremio catalog. But the idea is that you do have features like you can search data sets, you have a built-in wiki, so you can document those data sets. So if I'm a data analyst, the only thing I'm going to see when I log in are the data sets I've been granted access to. So the admin account may have access to the 10 raw data sources, all sorts of curated views of joins and whatnot. But all I'm going to see as the analyst is the specific data sets and spaces and folders that I was granted access to. And on any of those, any of those objects, I can actually see documentation on. So there's a wiki feature where I can go sit there and see like, hey, what is this data source? Maybe you document what the schema of that data source is. So I can basically see what data I have access to. I can search. So there's actually a search. So I can sit there and say, hey, find me this data set, and it can come up on the search. But also when I look at it, I can find the documentation to know exactly what that data set is, what the context of that data is, and all that. And then basically using every user on their account, they're able to generate tokens, so that way they can access it through like the REST API, through the Aeroflight endpoint, through JDBC, ODBC. And since they're using their token for their user account, all the same access rules apply. So if they try to access other data sets through the REST API, they won't be able to. They'll only be able to access the same things that they can see on the Dremio UI, because that's what their specific account has been granted access to. And then all the queries, regardless of where they're coming from, all become auditable in the jobs list. So if someone sends a job through the REST API, you can see that in the jobs list. If they send that job through Aeroflight, you can see that in the jobs list. Did they do it on the Dremio UI? You can see that in the jobs list. So all that stuff is very visible and auditable. And again, for them, it's pretty easy because they just log in, they can see the data. And then again, they can easily access it through, through the REST API, through Aeroflight and JDBC, ODBC, where they can just send SQL over, get the data back into their notebook, feed it into Pandas data frame, a Polar's data frame, a DuckDB relation, like I'll talk about next week. So data discoverability is pretty key. It makes it really easy just to know, hey, this is what I got access to, and here's how I can access it. Is Dremio available on-prem or only as a cloud solution? Both. So there's essentially, there's the cloud service. Okay, and the cloud service has the extra benefit of the integration with the Dremioarctic catalog. Okay, so that basically at the end there, Colin was talking about dataascode. So like being able to create versions of your catalog of data, which is a cloud service. So that Dremioarctic service is what provides this data catalog where you can version tables, specifically iceberg tables, and you can actually version your views that you create on Dremio. So even your views on other data sources become part of that catalog and can be versioned and create multiple environments and all that. But that's on the self-deployed on-prem version, Dremio software. So usually the terminology is Dremio Cloud and Dremio software. You can self-deploy. It does have a Nessie connector, because at the end of the day, Dremioarctic, that cloud catalog service, is powered by an open source technology called projectnessie. So you could self-deploy a Nessie catalog or use Dremioarctic's cloud catalog and still connect it to your on-prem deployed Dremio. And that can be done through AWS, that could be done through Azure, that could be done through Google Cloud, or that could just be done through Kubernetes. Basically, you have lots of different deployment options when it comes to Dremio on-prem. And the things you can start for free. There's a Dremio Community Edition that you can deploy on-prem for free, and so that way you can evaluate Dremio and then kind of see if you want to go upgrade from there. And when it comes to Dremio Cloud, a Dremio Cloud account is free. The only cost you would have is any infrastructure cost, as far as like compute instances and stuff like that. But then later on, if you want to get some of the features that are available in the enterprise accounts, then you can exploit enterprise accounts. So you can start enjoying the benefits for Dremio right away at no cost, other than any kind of infrastructure, compute instances, storage that you have to spin up for your cloud or on-prem infrastructure. Okay, how can data certified confidential levels be? Let's see here. How can data classified, e.g. confidential levels within Dremio? Well, there's a couple different ways. Like I'm interpreting the question as like, how can I create like different levels of access? And I mean, there's different ways you can do that. You can create different user roles. So you could, so you could create different shades of sort of access, basically by creating a role that represents that level of access. So by that, you can always just give access to particular data sets just to that level of access. But even better, so let's say you have a particular data set or a particular view that, let's say, all the tiers of access have access to, but there's PII, and only the, like, say, the highest tier should be able to see that PII in that particular view. You can create UDFs that check, okay, hey, what's the level of access? So I'll say, okay, hey, if the user role is this, then then X, then they'll either see a masked version of the data. So maybe they only see the last 4 digits of the social, or maybe they see the full social. And then you can apply those UDFs as column and row masking rules on the data set. So that way, when the right people see the data, they see the right version of the data. Okay, so that way that people who shouldn't see X columns don't see X columns, but you don't have to create like 10 copies of the data because you have 10 different levels of security. You can basically programmatically apply that governance using Dremio's column and row masking rules and role-based access rules. And then if you're working on-prem, so if you're deploying on-prem and you're using something like Hive, there is also integration with like Ranger for those kind of use cases. Cool. Any other questions? I think we got a few more questions right over here. How can Dremio govern data from other sources? Okay, so bottom line is this. Dremio acts as the access layer. So basically, everything connects to Dremio, and then you curate views from there. Okay, and basically you avoid duplication of the data by curating logical views instead of physical views. And then what you do is that every other user assumes zero access to anything from the get-go. You have to grant the individual things you want them to have access to. So they may never see the raw sources. All they're going to see is the specific views that they're going to have access to. And it doesn't matter where that data is coming from, whether it's coming from, because you can connect things like, you can connect data warehouses like Snowflake and Redshift. You can connect databases like Postgres, MongoDB. You can connect data lakes, like whether it's an S3 data lake, or you're using AWS Glue catalog, or you're using a Nessie-based catalog like DremioArctic, which is a self-deployed Nessie. Whatever it is, you can connect it to Dremio, and then you just curate the views, and then everything starts off with sort of zero access to anyone but the admin user, and then you grant access, and you grant the level of access. Okay, so just because you grant access to somebody doesn't mean they can manipulate it, create views on it. There's different tiers of access you can give them. Maybe they can just read a particular view. Maybe they're allowed to generate reflections on that view. Reflections are a feature that, think of them as like a sort of super smart materialized view, but a little bit different. Basically, take all the problems you may have with materialized views and fix them. That's what data reflections are. And you can give people the ability, if they can, to toggle that on. So you can get very granular with the level of access you give, and you can do it on all your data sets all from one place, which is the beauty of it. Okay. Are there any problems with resource contention? How are queries scaled? Now, that depends on, well, actually, either way, whether it's on-prem deployed software or in the cloud, you can create sort of multiple clusters. Okay, so multiple sort of compute engines. And what you can do is you can have different routing rules. So basically, you can route rules based on like user roles. So you can say, hey, people with this particular user role, maybe their queries aren't as high priority, so they get routed to a lower cost compute engine. Vice versa, people with a particular role whose queries are maybe more higher priority get routed to so that way the resources are being used for the particular queries that you want, and you can do that based on the particular data set. Like there's a lot of room for how you create those routing rules. So it's almost like its own little language, but based on any kind of factors that are within the Dremio system, you can determine, okay, hey, queries on this data set go to this. Queries by this user go to that, and you can route those engine rules. So that way you can manage the actual compute resources to be used for the queries that are your top priority. And an extra benefit sort of on Dremio Cloud is that you can actually, those compute engines can be auto-scaled. So in that case, you could sit there and say, okay, hey, this particular compute engine, I want to enable concurrency, so it can automatically spin up, other copies of that engine, and you can maximize that concurrency and say, hey, I max concurrency 10. But then what it can do is it'll scale it down, and then you can say, hey, what are the minimum number of concurrent units of that engine that should exist, and how much time without usage should it shut down? So that way you don't have to worry about dangling compute instances, because you can say, hey, 0 is the minimum, and shut them down if they're standing idle for like 5-10 minutes or something like that. And then that way, basically when all the queries just stop kind of coming in for a period of time, all that compute shuts down. You're not incurring that additional sort of cloud infrastructure costs. So there's that angle of it. Also, when it comes to sort of resource situations, when it comes to like push down queries. So for example, if I'm joining a data set with like, let's say MongoDB, and I'm joining it with a MySQL table that are both connected to Dremio, the initial way that's going to happen is that's going to push down those queries. So initially it's going to push down to MongoDB, it's going to push down to MySQL. And, you know, depending on what infrastructure you're using there could be potential like latency issues. And then it's going to take that data and then do the join, and then Dremio will take it from there. But what you can do is you can use, this is where a great use case for data reflections is. So what you would do is you would turn on data reflections on the join. So on the logical join view, you just literally flip a switch, turn on data reflections, and what it's going to do is create a materialization, and actually Apache Iceberg based materialization. So you get the benefits of Apache Iceberg under the hood of that join view set. So then what happens is that now any queries on that join are going to be accelerated. So they're not going to have to deal with that sort of contention of the pushdowns. And then two, if anyone creates additional views based on that join, those views will use that Apache Iceberg based reflection to accelerate themselves as well. So it's not like a materialized view where you have to have a separate namespace and you have to create a separate materialized view for every possible view you want to materialize. Basically, just by creating that data reflection in the view, you've created acceleration on that particular view and every view derived from it. Because basically, Dremio will always sort of, when it's processing the query, will evaluate, hey, does this view or any of its parents in its lineage have reflections on it, and whether those reflections can accelerate the query that it's about to execute. And you can actually have multiple reflections on the same data. So maybe you have different types of query patterns on the same data set. So basically, you would like to have the data partitioned in two different ways. So normally what you would do is you'd end up having to create two different copies of the data partitioned differently to satisfy both query patterns, to make sure that they're both nice, crisp, and fast. But with Dremio, you can just create two reflections, specify the sorting and partitioning rules of those reflections, and everyone just keeps querying the same view. So like the namespace they're querying, they don't even have to be aware the reflections are there. They're just querying that same join that they're aware of, and they're just going to notice that their queries are a lot more crisp, because Dremio under the hood is going to say, okay, hey, this is the query. This is going to lean to the reflection that has this pattern, this partitioning pattern better. So it's going to use that reflection to actually execute the query against, giving you that better performance. So it gives you a way of sort of engineering performance and engineering sort of the support for that performance for really, really large data sets that also makes it easier to use for your end user, because again, they're not having to like scramble between like 20 different namespaces for the same data set. Okay, let's see if there's any other questions. How can I govern my data at the source level? Okay, so basically a couple like food for thought. Let's say you want to do all your governance in Dremio. So you want no one to access your data through any other means but through Dremio. So essentially you connect all your raw data sets to Dremio, everything's kind of curated from there, and then that's that. What you can do is you can pretty much shut down, depending on your different sources, you can just basically cut off access and say something like, you know, like if I'm using like AWS, I might say, hey, that all the queries have to, you know, basically I block off all queries except unless the queries are coming through like the VPC that Dremio is deployed on. So then only really Dremio can communicate with those data sources that are running on in this virtual private network on AWS, because all their ports and all their public access has been shut off, but the public can access it because they can access it through Dremio, which is running in that VPC. But again, their access to Dremio is governed by the rules of Dremio. In that case, you basically have shut off all other access, and they only have that one way of accessing the data that is well, again, auditable, governable, and generally pretty easy to manage. Like everything can be done through the UI. Everything can be done through SQL. And because you can do it through SQL, everything can be automated. So you can automate a lot of the governance actions of like setting up new users, assigning them roles, because all of that can be, you know, you can create like a script that runs, let's say, create a script in Python that just makes the right API call, sending over the right SQL, and those actions have been taken. All that SQL then all those jobs are then also auditable in the jobs list. So everything becomes very visible and transparent, but also maintainable and doable. Okay. Cool. I see one more so far. Okay, what kinds of fine-grained access control does Dremio support? Okay, we kind of talked about this already, but I'll just kind of rehash it. Again, with Dremio, you have access. You can say a particular user has access, or a particular role has access to any view, folder, or space. Okay, and then And a space could be the same as like a catalog. So basically a Dremionessie or Arctic catalog acts very much like a space typically does in Dremio, which is a place where you can store views. The only difference is that a Arctic or Nessie based catalog can also store physical iceberg tables. But basically you can do it at that sort of bucket layer. So like that sort of that catalog layer, at the individual folder layer, or at the individual view layer. You can grant access to any user or any role. And then you can determine what level of access to give that role or that user. And then based on their role or username, you can create column and row masking rules on any data set. So you have lots of different levers to pull for that security. Okay, and let's see, any other, it actually looks like there might be another question right over here. So let me go grab that one. How does billing work? Is it pay as you go, or is there reserved instances? I think it's depending on, if you're talking about Dremio Cloud, it is consumption based. So now generally I don't work on the pricing side, so that would be a discussion with sort of like a one of the Dremio account AEs and SAs, and we can definitely set up that conversation to kind of discuss sort of your particular situation. Now if it's Dremio software, I think it's more on a like year-to-year contract, so you basically we'll discuss sort of what your needs are for the year, and then renew the following year, and so forth and so forth. So it's, I think, more of not consumption based in that situation. But either way, again, to get your initial start, you can deploy Dremio Community Edition on-prem, or use Dremio Cloud online at an initial cost of free. Basically, what you're upgrading for is just for a few additional features, like they are security features, like the additional features you get with the upgrade, and additional support. But if you're just looking to kind of try out Dremio and see how a lot of those features are initially, you can deploy for free. You can get Dremio Cloud for free, try it out, see how it feels, see how your users like it. Generally, once they start seeing that they can see all their data sets in one place and easily access it through, REST API calls or JDBC or Aeroflight, especially like there's a library I published on Python called Dremio Simple Query that makes this really easy. You literally just pass your token to a function, and then you just pass the SQL you want, and you get all your data from, you get whatever data you have access to from Dremio pretty easily in your Python scripts. Once people actually use it, they're like, okay, this is great. And then, and then from the analyst side, and then from the engineering side, when they realize, hey, look, I just go to this one panel and I can control this access, they're like, this is great. But, again, you can always try it out first. And then we're always, again, here to talk about helping you set that up. So I definitely always encourage sitting down with an SA and AE, so that way they can understand your specific use cases, to give you kind of best practices how to deploy and how to use Dremio for your particular use case, because Dremio is a very flexible tool. It can help people in creating more data. Like I've seen customers that their main purpose for Dremio is to kind of create that layer over all their data sets for them to build applications on top of. So they have all their data, and then they use the REST API to build applications that their customers have access to. I've seen that people use it just to kind of reduce a lot of the latency in data requests for their data analysts, so that way they can operate and self-serve much more quicker. They can serve a lot of different use cases. So again, with SAs and AEs are always glad to sit down and have that conversation to figure out, okay, sort of what is the best plan of attack for you, and then basically if it's the right tool and if there's the right plan, then you can always get into that, see how it works, and then have that discussion about, okay, what is the next step? So what are your needs, and what does that look like cost wise? Okay, can you say a word about ML AI functionalities in Dremio? Now, at the end of the day, Dremio is essentially delivering the data. Okay, so as far as like if you're doing AI or ML, you would still just basically probably do a lot of your work maybe out of a notebook or something like that, using whatever source of your notebooks that you prefer. But Dremio can then, what Dremio does for you is provides you access to that data that's easy to access and fast to access. Because again, you can turn on those reflections on data sets that may take a really long time, that sometimes getting access to is a little slow. Something that has been announced down the road, so this is not a feature that exists yet, but this will be useful for like AI ML down the road, is that the concept of sort of like a vector lakehouse. So the idea being that in the future, through Dremio and inside like that Dremioarctic catalog, you'll be able to actually like save vector data. So that way you can use that for sort of like AI type models and create oh, totally forgot the word at the moment, but basically be able to track those mappings of different vectors that can be used. But yeah, so bottom line, Dremio is more of an access layer. You can do whatever you want with the data: AI, ML, analytics, BI dashboards, and especially for like BI dashboards, you have features like aggregate reflections that caches all the aggregate values that really make BI dashboards really nice and crisp. But either way, data reflections can materialize the raw data, again, partitioned how you need it, or sorted how you need it. You can cache with aggregate reflections. All of that can sort of satisfy pretty much any data use. But the main thing is like creating that access layer for easy access, governed access, and easy management. So that way, basically, people just focus on what they're doing with the data instead of having to focus on how does the data get there and how do we monitor that. So that's sort of where like Dremio plays a role. So basically, Dremio is going to make it where that data is available for whatever use case you want. Okay, I think there's another one below that. Let's scroll down. So Dremio IE would be connected to my data for or any tool to grab the data fast. Yep, yeah, like basically whatever tool you're using. So I'm gonna assume like, let's say you're using a notebook. I mean, you would just basically in your notebook grab the data through one of Dremio's access layers, so that either through JDBC, ODBC, the REST API, or through Aeroflight. Again, if you're using Python, that Dremio simple query library that I made makes it accessing through Python really, really easy through Apache Aeroflight, which is going to be the fastest way to transport that data, because basically the data stays columnar throughout the entire transport path. But also there are tools out there that have Dremio integrations and basically will already have that built-in integration either through one of those ports, so that way you don't have to worry about setting that up. That you'd have to look into the specific tool and whether it has a Dremio integration. But again, anywhere you can always use the REST API, JDBC, ODBC, or Aeroflight to pull the data into any notebook anywhere. Okay, and now I think that was the last one. Okay, well, lots of great questions. And again, I always appreciate you guys coming to visit us every week here at Gnarly Data Waves. Next week, we'll be talking about Dremio and DuckDB. So again, using Dremio as that amazing access layer, but also thinking about like, how can you maximize your compute on your local laptop? And that's where like DuckDB and Dremio can be a really nice pairing, because Dremio can really organize and govern your whole data world, but then your analysts can then do a lot more work using their local compute, using DuckDB locally, but using Dremio as that layer that kind of funnel all that data through and making sure that all that data is governed and auditable, and you know who accessed what, kind of thing. So join us next week again, same bat time, same bat place, over here in Early Data Waves, and thank you very much. I'll see you all next week.